Have you ever wondered how your smartphone does so much? Or how your fitness tracker counts your steps? It's not magic. Hidden inside these devices is something called firmware. Think of firmware as the set of instructions that tell your device what to do. It's like a mini computer program embedded directly into the hardware. Without firmware, your gadgets would just be pieces of plastic and metal. Firmware is essential for everything from controlling your microwave's timer to flying a drone. It's what makes our devices smart and allows them to interact with the world around them. In this guide, we'll explore the world of firmware and learn how to write our own using a platform called Arduino. Get ready to unleash your inner maker. So, what exactly is firmware? In simple terms, it's the software that makes your hardware work. It's the bridge between the physical device and the user interface you interact with. Let's break it down. Hardware is the physical parts of a device, like the buttons, screen, and circuits. Software is the programs you run on a device, like apps on your phone. Firmware is the low-level code that controls the hardware directly, making it responsive to the software's instructions. Firmware is usually stored on a memory chip within the device and runs automatically when you power it on. It's responsible for tasks like managing power consumption, communicating with other devices, and executing the functions triggered by your interactions. Ready to start coding your own firmware? Great! Whether you're a seasoned developer or a complete beginner, diving into firmware development can be an exciting and rewarding journey. Let's walk through the essential tools you'll need to get started. You won't need a fancy lab, just a few essential tools. First, an Arduino board. This little device is the heart of many DIY electronics projects. An Arduino board is like a mini computer designed for easy programming and prototyping. It's versatile and user-friendly, making it perfect for both beginners and experienced developers. It's the perfect platform for beginners to learn firmware development. Next, the Arduino IDE. This software is your gateway to writing and uploading code to your Arduino board. The Arduino IDE, or Integrated Development Environment, is the software you'll use to write, upload, and test your firmware code. It's designed to be intuitive and easy to use, even if you've never written a line of code before. It's free to download and use. Simply visit the Arduino website, download the IDE, and install it on your computer. Within minutes, you'll be ready to start coding. You'll also need a USB cable to connect your Arduino board to your computer for programming and power. This connection is crucial as it allows you to upload your code and power your board simultaneously. Depending on your project, you might need additional components like LEDs, sensors, motors, or buttons. These components can help you bring your projects to life by adding functionality and interactivity. These are readily available online and at electronics stores. You can find a wide variety of components to suit any project, from simple LED blinkers to complex sensor arrays. Finally, a breadboard and jumper wires are optional but helpful for building and testing circuits before soldering them permanently. They allow you to experiment and make changes easily without committing to a permanent setup. With these tools in hand, you're well on your way to creating amazing firmware projects. Happy coding? Section 4. Let's make a light blink. This is one of the most exciting and fundamental projects you can start with when diving into the world of Arduino. It's simple, yet it opens the door to endless possibilities in electronics and programming. Let's dive into a classic beginner project, making an LED blink using Arduino. This project will not only teach you the basics of working with Arduino, but also give you a sense of accomplishment as you see the LED light up and blink according to your commands. This simple exercise will teach you the basics of firmware coding and get you familiar with the Arduino environment. Step 1. Setup. Setting up your Arduino board is the first crucial step. It involves connecting the hardware and ensuring that your computer can communicate with the Arduino board. Connect your Arduino board to your computer using the USB cable. This connection not only powers the Arduino, but also allows you to upload code from your computer to the board. Open the Arduino IDE and select the correct board type and port from the Tools menu. The IDE, or Integrated Development Environment, is where you'll write and upload your code. Selecting the correct board and port ensures that the IDE can communicate with your specific Arduino model. Copy and paste the following code into the IDE editor. This code is a simple program that will make the LED blink on and off at 1-second intervals. C++// define the LED pin. This line of code sets up a constant integer that represents the pin number where the LED is connected. const int lead pin =13 void setup. This line initializes the LED pin. The setup function is where you configure the initial settings for your Arduino board, / set the LED pin as an output. This comment explains that the next line of code will set the LED pin as an output pin. Pin mode, lead pin, output. Void loop. The pin mode function is used to set the LED pin as an output. The loop function is where the main code runs repeatedly. / turn the LED on digital write lead pin high. This line of code turns the LED on by sending a high signal to the LED pin. Delay 1000 / wait for 1 second. The delay function pauses the program for a specified amount of time, in this case 1 second. / turn the LED off digital write lead pin low. This line of code turns the LED off by sending a low signal to the LED pin. Delay 1000 / wait for 1 second. The delay function is used again to pause the program for another second before the loop starts over. Step 2. Understanding the code. Now let's break down the code to understand what each part does. This line defines the pin on the Arduino board where the LED is connected, which is pin 13. Defining the pin number makes it easier to reference the pin throughout your code. This function runs once at the beginning of your program. The setup function is crucial for initializing settings and configurations that only need to be done once. Here we set pin 13 as an output using the pin mode function. This tells the Arduino that pin 13 will be used to send out signals rather than receive them. This is important because it prepares the pin to control the LED. This function runs repeatedly after the setup function. The loop function is where the main logic of your program runs continuously. It allows the Arduino to perform tasks over and over again. Inside the loop we turn the LED on using the digital write function. This sends a high signal to the LED pin, turning the LED on. This is the first action in our loop. Wait for 1 second with the delay function. This pause allows the LED to stay on for a visible amount of time. Without this delay, the LED would blink too fast to see. Turn the LED off using the digital write function again, but this time with a low signal. This turns the LED off. This is the second action in our loop, and wait for another second. This second delay keeps the LED off for a visible amount of time before the loop starts over. Step 3. Uploading and running. Now that we understand the code, it's time to upload it to the Arduino and see it in action. Click the Verify button, which is the checkmark icon, to check for any errors in your code. This step is crucial to ensure that your code is free of syntax errors before uploading. Once verified, click the Upload button, the right arrow icon, to transfer the code to your Arduino board. This process compiles your code and sends it to the Arduino. Observe the LED connected to pin 13 on your board. It should start blinking every second. Congratulations, you've successfully completed your first Arduino project. This is just the beginning of what you can do with Arduino. Section 5. Firmware is everywhere. Firmware is the invisible force that powers the modern world. It's embedded in almost every electronic device you can think of, making them function seamlessly and efficiently. Firmware is the unsung hero powering countless devices we use every day. From the moment you wake up and check your smartphone, to the time you set your alarm clock before bed, firmware is at work behind the scenes. Let's explore some real-world applications. Consumer electronics, smartphones, laptops, and TVs are just the tip of the iceberg. These devices rely on firmware to manage everything from booting up to running complex applications smoothly. Gaming consoles and cameras also depend heavily on firmware. It ensures that your gaming experience is immersive and your camera captures the perfect shot every time. And smart home devices, from lights and thermostats to speakers and security systems, all rely heavily on firmware for their functionality. Firmware allows these devices to communicate with each other and with you, creating a seamless smart home experience. Automotive modern cars are packed with firmware controlling everything from engine performance and safety features to entertainment systems and navigation. Firmware ensures that your car runs efficiently, keeps you safe, and provides entertainment on the go. Robotics and automation, industrial robots and drones are revolutionizing manufacturing and logistics. Firmware is at the heart of these technologies, enabling precise movements, sensor integration, and task execution. Medical devices, pacemakers, insulin pumps, and other automated systems depend on firmware for precise movement, sensor integration, and task execution. These devices use firmware to monitor vital signs, deliver medication, and ensure patient safety. Medical devices like pacemakers and insulin pumps use firmware to monitor vital signs, deliver medication, and ensure patient safety. Firmware is crucial in the healthcare industry, providing reliable and accurate performance. Internet of Things, IoT. The interconnected world of smart devices, from smartwatches and fitness trackers to smart appliances and industrial sensors, is built upon a foundation of firmware. Firmware enables these devices to communicate, share data, and work together seamlessly. Firmware is the backbone of the IoT ecosystem, ensuring that all devices function correctly and efficiently. It allows for real-time data exchange and remote control, making our lives more convenient and connected. As technology advances, the role of firmware will only become more critical in shaping the future of our interactions with the world. From smart cities to advanced healthcare solutions, firmware will continue to drive innovation and improve our quality of life.